In this video, we will learn about multidimensional array. The learning objectives of this video are that the student will know how to declare multidimensional array, and then the student will know how to access multidimensional array. What is multidimensional array? A multidimensional array, it is an array which consists of more than one dimension, and it can be used to represent matrix and then objects within multidimensional coordinate system and other data which contain multidimension. The declaration of multidimensional array is similar to the single dimension, where the size of the array must be defined. So this is the key, that everywhere we declare an array, whether it is single dimension or multi-dimensional, so we have to define the size of the array. So here is the example of multidimensional array, and here we have two-dimension array. So the first multidimensional array here, we do not put any value or element inside of the array, but we just define that the two-dimensional array with the name of data has the size of the first dimension is 5 element, and then the second dimension is 4. So we will have 4 memory spaces, and then it will be 5 times. So they are 5. For the ease to mention that the first index, it will be indicate the row of the array, and then this second dimension will be the column of the array. And then if we want to access this two-dimensional array, we can just call the name and then give the first index, this is the column index, and then we give the row index. And in this second example, we can directly give the element of the array by using this statement. So at first, we will make the first curly bracket. This first curly bracket means that this is the whole array, and then inside of the whole array we have 3 sub-arrays. This is the 3 sub-arrays, and it will be the size of the first dimension. So this is the row, and then inside of each row we have 4 elements here, and we can see that the size of the column will be 4 here. When we are declaring a multidimensional array, it is necessary to give the size of the dimension except the first dimension, except for the first dimension. If we put or if we declare the element of the array explicitly directly in the declaration, but if we do not have the element in the declaration, then we have to write down the size like this. Okay, so one of the dimension, the first dimension, it is not necessary to be defined the size of the array. However, you have to explicitly write down this element. And then how to access this, just the same as the first example. And then the next example here, I will demonstrate how to get the size of the the two-dimensional array. So this is the size of the column and this is the size of the row, and you can detect the size automatically by using size of, right? This is just like the example in the single dimensional array. However, you have to know how to get the size of the column and you have to know how to get the size of the row. So how to get the size of the column is that you take the size of the data 0. It means that the size of one row. So the size of one row is 4 element of integer, right? And then you divide by the size of single element, this one. So if you have that data 0, that data 0 is 4, and then you divide with the size of data 0, 0, so it is only 1, like this. So you will have the size which is 4. And then what is the number of, or the size of the row? You can get from take the wall size of this array. So the wall size of the array is 1, 2, 3, 4 multiplied by 3, so it is 12, right? And then you divide by the number of the column that we have here, which is 4, and then you multiply with the size of integer. So this this memory allocation for the integer. Therefore, you will have 3 rows for the size of the end row. Then you can use in accessing the two-dimensional array using iterative command, and you can put here with the end row and end call, so you do not need to put the static number. And then the next example is, this is the example of how to represent matrix with two-dimensional arrays, and then we will do the transpose of this array. So we have this matrix like this, and then we want to transpose it. So the row will be column, just like this. We transpose. So how to do this? When we do the transpose, it means that we interchange between this element 4 with this element 2, and then this 7 with 3, and then 8 with 6, and just it. So we can do the swap, I call it a swap, by doing only for this element or this element. So I will do only in the upper triangle or in the lower triangle, so the diagonal will be still the same, and then the upper triangle I will do the swap with the lower triangle. So how to implement in the program, I will do like this. So it is starting from 0 to 3. It starts from the row 0 until 2, index 0 until 2, and then in the each index, in the each row I will swap, which is I plus 1. So suppose I am in the row 0, then I will swap I plus 1. It means that I will swap this column and then this column. When I am in the second row, I will swap, because I am in the second row, so my index will be 1. When I'm in the second row, so the index will be 1. 1 plus 1, it will be 2. So I will swap this. So I think I will erase this. So I only swap the upper triangular matrix with the lower triangular matrix. So this is how to define the iterative comment by using for. The result of this program is that your matrix will be transposed into this matrix. So now we will see the example of three-dimensional matrix. So how to define three-dimensional matrix? When you have three-dimensional matrix and you want to declare the value just after you declare the three-dimensional matrix, then you can do like this. First, you have this biggest curly bracket. It means that this is the dimension of the first. This will be the first dimension. Okay, and then you will have the next curly bracket. The next curly bracket, I will give a different color so that you will know the couple. So this is the second bracket. This will be for the second dimension. Okay, and then in the last dimension we have another bracket. So this one, this and this. So if you want to see the size of your three-dimensional data array, then you just calculate for the first level how many comma that you have. I will erase this. How many comma that we have. So in the first dimension we have this is the first comma, this is the second comma, third comma, and fourth comma. So I will have 4 size for the first dimension. And then if you want to see what is the size of the second dimension, then you just see how many comma inside of the second dimension. So you can see here that you have 1, 2. So you have 3 elements inside of it. I'm sorry, I think I made mistake that this comma is not necessary. Okay, so it's still 4. And in the second dimension we have 1 and 2 commas. So it means that we have 3 elements inside of it. So the size of the second dimension is 3. And then how if we want to see the last dimension, what is the size of the last dimension? We just see how many comma that we have inside of the curly bracket. We have only 1 here. So it means that there are 2 elements. So the size of the last dimension is 2. This is how you uh, declare three-dimensional array with its element. And then how to access it, you just indicate what is the first index, and then what is the second index, and then what is the third index. Just it. Okay, now you can answer this quiz. Is it compulsory to put the size of the multidimensional array when declaring it? Is it compulsory? The answer is no, especially for the first dimensional size. And provide the elements. Okay, and then how many curly bracket does the 3D array have? So if you have 3D array, then you have 3 curly bracket. Okay, we will meet in the next video.